We have a quadratic expression raised to the power of another quadratic expression equal to 1. And the question is, how can we get some values of x where that's going to work? Let's think about what we can raise to the power of something else to give 1. Well, 1 to the power of anything, maybe I shouldn't call it x because I've got x in the equation, I'm just going to put a question mark, is always equal to 1 for any value. Meanwhile, any value to the power of 0 is also 1. Just one little situation we need to be careful of is that 0 to the power of 0 is technically undefined. And then there's a sneaky one that you need to be aware of, that -1 to the power of an even number is also equal to 1. So that's going to give us our different cases for this question. So let's take them step by step. So maybe I call this case 1, case 2, and case 3. So case 1, 1 to the power of anything is equal to 1. Well, I can set, therefore, my x squared minus 7x plus 11 equal to 1, which means x squared minus 7x plus 10 is equal to 0. This factorizes x minus 2, x minus 5. So x is equal to 2 or 5. And it actually doesn't matter what the exponent's going to be, so I'm not going to check it. Case 2 is going to be when this power is equal to 0. X squared minus 4x plus 4 is equal to 0. This is x minus 2 squared, and therefore x is equal to 2 again. Okay, we don't get any new solutions. So actually, this gave us 1 to the power 0, in fact, when we did substitute 2 in. And yeah, this solution's fine, but we've already got it. That leaves case 3, which was x squared minus 7x plus 11 is equal to minus 1. So x squared minus 7x plus 12 this time is 0, which again factorizes. So x is equal to 3 or 4. We just need to check that the power is even. And I can just actually, use the factorized form, check that x minus 2 squared is even. When x is equal to 3, x minus 2 squared is actually going to be just 1, which is odd. So we need to reject it. When x is equal to 4, x minus 2 squared is going to be 4, which is even. So in fact, we are indeed going to get minus 1 to the power of 4, and hence we will get 1 as a result. So therefore, x equals 2, 5, or we have this other one, 4. Looking at this other part, B, actually we've already done most of the work for this. Find all whole numbers x such that this is true. The only way we can get minus 1 with our whole numbers is going to be if we have minus 1 to the power of an odd number. And we actually already have that from the case 3. So from A, x is going to equal 3 because we had minus 1 to the power of 1, which gives minus 1. So I don't think we need to write any more, like we've actually already done, all the working. Okay, good.